This is the AP Calculus 2016 practice exam. We're going to be doing free response number 4 today, specifically with commentary on the 2020 test. And I believe all of number 4 could be on the 2020 test. Definitely fair game. In fact, I think it's likely that you'll have a problem where you have to do at least one of these. So it says consider the differential equation dy dx is equal to y minus 2 times x squared plus 1. Part A says find y is equal to g of x. So we're getting the original y equation. And our initial condition is g of 0 is equal to 5. So first we need to separate the variables, get the y's on one side, the x's on the other side. I would not FOIL this out. That's just going to make it harder. So if you would bring the y minus 2 underneath the dy and then multiply both sides by dx, you would have this. And now your variables are separated and we can integrate both sides. So this is going to be the natural log of the absolute value of y minus 2 is equal to 1/3 x cubed plus x plus c. And so now we can put our initial condition in. We have the natural log of 5 minus 2, so that's natural log of 3 is equal to, and then we plug in 0 here, so we would have equals c. All right, so we have the natural log of absolute value of y minus 2 is equal to 1/3 x cubed plus x plus the natural log of 3. They want you to solve for y, so we're going to have to get rid of this natural log, and the way you do that is exponentiate both sides. If you do that, the natural log there goes away, and you would have y minus 2 is equal to, okay, e to the natural log of 3, e and natural log goes away, and you just have a 3 there. So that's going to be like you're going to bring your 3 out front. E to the 1/3 x cubed plus x. So the final answer here is y is equal to, bring the 2 over to the right side, 2 plus 3e to the 1/3 x cubed plus x. I'd be really surprised if they don't ask you to do a differential equation on the 2020 test, because it's every year you have to do one, so that would seem to be fair game for one of the two problems, them to pick one of those. Okay, so, and the 3 out front, again, this is the same as e to that times e to that times e to that. So e to the natural log of 3, just bring the 3 out front, and we'll just leave the other 2 as pluses. Okay, pause the video if you need to. So part B says we want to take the limit as x approaches negative infinity of what we just found from part C. So hopefully, part A, excuse me, so hopefully you got that right. So it would be 2 plus 3e to the 1/3 x cubed plus x. So we're going to plug a negative infinity in. So that's going to be, if you do that, that's 2 plus, and the negative infinity would bring all of, it would end up bringing, you know, negative infinity would make it go to the bottom, right? So e to the, it'd be 3 over e to ultimately the negative infinity, or the positive infinity. If it's negative infinity, right, a negative exponent you bring down underneath, right? So 3e to the negative infinity would be 3 over e to the infinity. Well, this is just going to go to 0, right? 3 over an infinite number would just go to 0, so the answer is just 2. All right, there's nothing to plug in with the 2, so it's going to be 2. If it had been towards positive infinity, then it would be 2 plus infinity, so it would be infinity. All right, so that part is pretty easy. Okay, let's take a look at part C. So part C says we have the initial condition f of 1 is equal to 3. We want to find the second derivative, so at the point 1, 3. So we want to find that, and we want to know if it's concave up or concave down. Okay, so first of all, let's figure out, we're going to need to figure out what dy dx is at 1, 3. So that'd be 3 minus 2. I'm just plugging in to dy dx. 3 minus 2 times 1 squared plus 1. So that's going to be 1 times 2, which is 2. Now let's take the second derivative, and what we want to do is do a product rule. So the second derivative is going to be the first, y minus 2, times the derivative of the second, 2x, plus the second, x squared plus 1, times the derivative of the first. What's the derivative of y minus 2? It's just dy dx. That's why I needed to get the value of dy dx. So the second derivative at the point 1, 3, we're just going to plug in. That'll be 3 minus 2. We're plugging into the second derivative times 2 times 1. So you want to show your work here for the graders, plus 1 squared plus 1 times 2. dy dx, remember, is 2. Okay, so that's 1 times 2 times 1. So 2 plus 2 times 2 is 4, 6. Okay, so that is one of the answers. Okay, is it concave up or concave down? Well, since the second derivative is greater than 0, it is concave up. Right? Remember, second derivative greater than 0, concave up, less than 0, concave down. Okay, so that's number 4. All 3 parts of those, I believe, are absolutely fair game for the 2020 test. So this is a good problem to study. And I will talk to you next problem.